All right, 11.2, compound interest for loans of more than 1 year. The interest paid on the money borrowed is called compound interest. The frequency with which the interest is compounded is called compounding periods. Called the compounding periods. Give you a chance to write that down. All right, compound amount formula. A is equal to P times 1 plus R over N raised to the N times T power. So all of our letters represent the same thing from last session, wherein A is your future value, P is your principal, R is your rate. You want to put that in decimal. T is your time in years. And then N is the number of compounding periods per year. So N is the new variable that we're introducing. All the other ones are the same from the last session. Compounding periods for N. Normally they don't give you a number, they give you a term to let you know how many times it's being compounded per year. If it's annually, that means N is equal to 1. Semi-annually, N is equal to 2. Quarterly, N is equal to 4. Monthly, N is equal to 12. And then daily, N is equal to 360. Remember we talked about that last session as well. Banker's rule for daily is 360 instead of 365. All right, any questions on anything before we actually do an exercise? All right, so calculate the compound amount when $10,000 is deposited in an account earning 8% interest, compounded semi-annually for 4 years. All right, so write down your given pieces of information. We have P is equal to 10,000, R is 8%, which is 0.08. T is 4 because of 4 years, and N is semi-annually, so that means N will be equal to 2. put it in the formula. That's 10,000, which is your P times 1 plus 0.08 over 2 raised to the 2 times 4 power. Now, if you have the calculator that can do this, you can put it in just like we have it right here. And you don't have to do any extra steps. And if you have any issues with knowing how to use calculator, feel free to email me. We can set up a session where you can show me your calculator. I can tell you what buttons to push, or maybe you can just send me a picture, and I can tell you what buttons to push. But that's an individual thing. I wouldn't take up class time, to take care of an individual issue. 10,000 times 1 plus 0.08 divided by 2 at caret top, and not caret top, but caret sign or hat, depending on who's saying it. That raises it to the exponent. And then parentheses 2 times 4. But if your calculator doesn't allow you to set it up using the parentheses and doing it this way, then you have to do order of operations when you have to take each step. Take it step by step in order to get the proper answer. You can go ahead and divide the 0.08 by 2, and you can go ahead and multiply 2 times 4 in your exponent. So that'll be a 0.04, and then that 2 times 4 is 8. And you add together the 1.04 inside of the parentheses. Add together, the 1 and the 0.04 inside the parentheses. That'll give you 1.04. Raise that to the 8th power. That's 1.368569, and times it by 10,000, 13,685, 69 cents would be your answer. All right. Questions? Any questions? All right. Next one. How much interest is earned in 2 years on $4,000 deposited in an account paying 6% interest compounded quarterly? So make sure you pay attention to the directions. Last one asked us to calculate the compound amount for 4 years, so they wanted their future value. They're asking us for the interest earned. All right, so first of all, we want to know how much is in the account after 2 years. So we go ahead and put our given information together. P is 4,000, R 6%, T is 2, N is quarterly, which is 4. Plug it into the formula. 4,000 times 1 plus 0.06 divided by 4 raised to the 4 times 2. That will give you 4,505.97 cents. And once again, you will follow the breakdown in the previous example if you want to get there without just throwing it in the calculator. And then to calculate the interest earned, you would do A minus B. So that 4505.97 minus 4,000, which was our initial amount that we deposited, that'll give you 505.97 cents. Questions? Any questions? Present value formula is the same formula that we've been using up to this point. It's just that it's solved for P. So it allows you to calculate what you need to deposit in order to get a desired amount after a certain amount of years. So how much money should be invested in an account that earns 8% interest compounded quarterly in order to have $30,000 in the account after 5 years? All right, write down your givens. Once again, I always say, make sure that if I'm scrolling up too fast or something like that, let me know. Of course, I can't see you guys, so I wouldn't know that you hadn't copied down something unless you let me know. So this time we want to know how much will we deposit or how much will we invest. So that's your P. That's what we do not know. And we want to have $30,000 in the account after 5 years. So this time A is 30,000, R is 8%, 5 is or T, and then quarterly. That means N is equal to 4. Use your present day formula. So it's 30,000 divide 1 over 0.08 divided by 4 raised to the 4 times 5 power. Make sure you use your parentheses accordingly. You will get the correct answer. And we should have to deposit $20,000 or $20,189.14. Any questions? All right, inflation is an economic condition during which there are increases in the cost of goods and services. All right, suppose your annual salary today is $35,000. You want to know what an equivalent salary will be in 20 years. Assume a 6% inflation rate. All right, 35,000 is P, 6% is R, 20 years T, and inflation rate is annual, so that means N is going to be 1. So put it in your future value formula, 35,000, 1 plus 0.06 over 1, and raised to the 120. Questions? Any questions? All right, effective interest rate The simple interest rate that would yield the same amount of interest after 1 year. All right. All right. A credit union offers a certificate of deposit (COD) at an annual interest rate of 3% compounded monthly. Find the effective rate using round to the nearest hundredth of a percent. I believe this is the last one out of 11.2. So to find the effective rate, the book said we should use 100 for P in order to be able to calculate it proficiently. So that's what we did. Use P for 100. 3% was your R. T is 1 year, and it happens monthly, compounded monthly. So once again, the book told us to use 100 to be able to find it. Everything else was in the year. I mean, not anything else was in the problem. Plug that in. 100 times 1 plus 0.03 divided by 12 raised to the 12 times 1. That's 103.4 cents or $103.04. A minus P, that's 103.04 minus 100. And once you get that at 3.04, that is actually your effective interest rate, 3.04%. Questions, concerns, comments before we do anything else? All right. So that is it for test three's content. Before the day is out, I will post the test review and the test. So for those of you who are behind, make sure you do your best to get caught up and do your best to work double time so that you could be in a decent place as you get closer and closer to the end of the session. Remember, if I'm not mistaken, I think it's November 15th. I got to go back to the dates. This session ends, so you don't want to depend on that December time frame. So make sure we're good. If you have any issues or anything I can do to help, make sure you shoot me an email so I can do so. We won't do anything else new today since that's closing out. We have time, but this is closing out a session. I mean, a test block. So I won't jump into anything new today. Next class, the floor will be yours for questions. If you do not have any questions, then we will jump into chapter 12. Before I close out today, questions, concerns, comments on anything? Anybody? All right, so I don't hear anything, so I hope that's great news. Hope that means everybody's okay. So, all right, got a hand. Go ahead, Miss Bergson.
Hi, good morning.
Good morning.
I just I was having trouble with I know this is about a different chapter, but
Hmm.
I had emailed you about like the percent increase and decrease. I was having some issues
Okay.
with that.
Now, did you have issues with actually finding it or like putting it in Connect Math or whatever?
Yeah, putting it in the formula, like I thought I did everything right, but when I put it in like WebAssign, it kept saying my answer was wrong.
Okay. Do you have a problem that problem that we can walk through, or you want me to just find one?
Um, I can try to get it.
Okay. If not, it's okay. I can go, go find it.
Yeah, that'd be good.
Okay. All right, give me 1 second.
All right, thank you.
Mm-hmm. Let's see. That was in. All right. So find the percent increase in the federal debt from 1995 to 2015, round to the nearest tenth of a percent. So there was a chart that he gave. So that's where we're getting these data values from. And so for 1995 is 4.92. 2015 is 1863, and these are in millions of dollars. So 4.9 million, 18.6 million. All right. So the way we will calculate percent increase is that we'll do amount of increase over the original amount times 100. But 100%. So the amount of increase will just be the 1863 minus the 492. That's 13.71. Then we'll do 13.71 over the original amount, which is 4.92. And let me write this part. So this will end up having a 278.7% increase, which is a lot, but that's how it happens. Sometimes it happens like that. Percent decrease is the same way. You will subtract the two values, place it over the original amount, and multiply it times 100%.
Okay, cool. Thank you so much.
Yeah, no problem, no problem. Also, make sure you guys watch out for that decimal place. Here they want us to round to the nearest 10th of a percent. So that's why we went there. All right. Anybody else before we close out? Everybody good? All right. So, once again, my door is always open, and you don't have to wait until class time to ask me for a question. And you just gotta wait for me to respond, though. Of course, yeah, give me that 24 to 48 hours. Outside of that, you guys have a good one. Be safe, and I will see you on next class.